Execution in computer and software engineering is the process by which a computer or a virtual machine performs the instructions of a computer program. The instructions in the program trigger sequences of simple actions on the executing machine. Those actions produce effects according to the semantics of the instructions in the program. Programs for a computer may execute in a batch process without human interaction, or a user may type commands in an interactive session of an interpreter. In this case, the commands are simply programs, whose execution is chained together. The term run is used almost synonymously. A related meaning of both to run and to execute refers to the specific action of a user starting a program, as in, please run the application. Context of execution. The context in which execution takes place is crucial. Very few programs execute on a bare machine. Programs usually contain implicit and explicit assumptions about resources available at the time of execution. Most programs execute with the support of an operating system and runtime libraries specific to the source language that provide crucial services, not supplied directly by the computer itself. This supportive environment, for instance, usually decouples a program from direct manipulation of the computer peripherals, providing more general, abstract services instead. Process. Prior to execution, a program must first be written. This is generally done in source code, which is then compiled at compile time to an executable. This executable is then invoked, most often by an operating system, which loads the program into memory, possibly performs dynamic linking, and then begins execution by moving control to the entry point of the program. All these steps depend on the application binary interface of the operating system. At this point, execution begins and the program enters runtime. The program then runs until it ends, either normal termination or a crash. Interpreter. A system that executes a program is called an interpreter of the program. Loosely speaking, an interpreter actually does what the program says to do. This contrasts with a language translator that converts a program from one language to another. The most common language translators are compilers. Translators typically convert their source from a high-level, human-readable language into a lower-level language that is simpler and faster for the processor to directly execute. The idea is that the ratio of executions to translations of a program will be large, that is, a program need only be compiled once and can be run any number of times. This can provide a large benefit for translation versus direct interpretation of the source language. One trade-off is that development time is increased, because of the compilation. In some cases, only the changed files must be recompiled. Then the executable needs to be relinked. For some changes, the executable must be rebuilt from scratch. As computers and compilers become faster, this fact becomes less of an obstacle. Also, the speed of the end product is typically more important to the user than the development time. Translators usually produce an abstract result that is not completely ready to execute. Frequently, the operating system will convert the translator's object code into the final executable form just before execution of the program begins.